Hello, and welcome to I Know Dino, the Big Dinosaur Podcast, where we cover news, interviews, and discussions of all things dinosaur.
Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And in today's episode, we have Dinosaur of the Day, Antetonitrus, and a bunch of dinosaur news. And as always, we would like to thank our Stegosaurus patrons. Specifically this week, we'd like to thank Scotty, Jackson, Megan Dixon, Eric Keller, Kessler, and Beth and Scott Wilson.
Yeah, thank you so much. Your support means a lot to us, and we really appreciate all that you do, and we love hearing from everybody week to week, and we appreciate all of our patrons. So if you'd like to join this awesome group of people, check out our page at patreon.com/iknowdino.
Jumping right into the news, first I want to do a follow-up from last week when we were talking about dinosaurs eating crustaceans. After we recorded, I went back and read some more in-depth into the article to try to see if I could find how they decided that it was hadrosaurs and not some other sort of herbivorous dinosaur, since they call it mega herbivorous dinosaurs in the title. So the reasons that they listed for why it was probably a hadrosaur is that the most common fossils from the area are hadrosaurs, specifically Parasaurolophus and Gryposaurus. But then they also found an ankylosaurid, a nodosaurid, a pachycephalosaurid, a hypsilophodontid, and 3 ceratopsians from the area, which could all be contenders for giving an herbivorous coprolite, or fossilized poop. So, first of all, they looked at the size of the coprolite, and that basically reduced it down into ceratopsians and hadrosaurs. But then they had found similar coprolites at 2 Medicine Formation that appeared to be from a hadrosaur, Maiasaura, and then finally they said, quote, "The crushing and shearing abilities of the dentition of hadrosaurs would have allowed them to effectively exploit a broader range of foods than the shearing teeth and jaws of ceratopsians," end quote. So it sounds like they're looking specifically at what the food looked like after it was all chewed up, and it looked more like hadrosaur chewing than ceratopsian chewing. So that's how they ended up at that result. But I could see how that could be hard to know, considering we've never actually witnessed a ceratopsian or a hadrosaur chewing. So that might be why in the title they stuck with mega herbivorous rather than specifically saying hadrosaur.
Makes sense.
Yep. In new news, there's an article published in JVP by Eric Gorsak and others that describes a new dinosaur from Africa, and this one's from the Galula Formation, which is roughly 100 million years old in southwest Tanzania. And it was found by researchers from Ohio and Australia because, of course, that's who's looking for dinosaurs in Tanzania. They named the dinosaur Shingopana songwensis, I think is how you say it. I don't speak Swahili, which is what the words are based on. So Shingopana is Swahili for wide neck. Shingo means neck and pana means wide. And then songwensis is in reference to the Songwe area.
That's a pretty name.
Yeah, I don't know if that's how you say that either, but it looks like it. They found about 10% of the bones from a titanosaur, including a left angular, which is the first time I've seen that written. But that's the back of the jaw behind and below the dentary, and the dentary is the part that the teeth grow out of. So it's kind of like back where the jaw joint is, can be a little bit more flexible in some animals, including dinosaurs.
So they could have opened their mouth really wide?
No, it's more like when they bit, it would move a little bit potentially. Kind of like in the middle of your foot or something like that.
Ooh.
More so than like an actual joint. Yeah. They also found several vertebrae, ribs, a partial humerus and pubis, which is part of the hips, and some other indeterminate fragments. But the most interesting thing about these bones is that many of them had holes bored in them by insects, presumably, and they found over 150 quote-unquote discrete borings. So those included 5 types of holes. One of them was called pupation chambers, which is likely from carrion beetles.
Ugh.
Basically, they burrow in and then lay their eggs, or they themselves develop into another stage and then come back out of the bone. This is all presumed to be done after the animal died and likely after it was buried as well. So it's not like this was happening to the living Titanosaur.
I would hope so.
Yeah. They also found some boring along the dry bone fractures. So if the bone broke or dried out and, kind of split a little bit, some things, presumably termites or ants, made a little colony in those parts of the bones. So it was really quite the ecosystem going in this dead Titanosaur all that time ago. On the other hand, there weren't any signs of teeth marks from predation or scavenging, so it might have gotten buried quickly and then some insects kind of made it their home rather than the typical kind of scavenging that we see. In terms of the dinosaur itself, it was about 8 meters or 26 feet long and about 4 meters or 13 feet tall, and it probably weighed about 5 tons. We don't have the femur, so again, that's kind of the main bone you use for that, but the humerus was nearly complete, so it's probably pretty close. When they did the phylogeny, or kind of that cladogram showing what the close relatives are, they found that it had more in common with titanosaurs from South America than those from Africa, and they believe that that's more evidence of an early to middle Cretaceous link between the continents. And another interesting thing is this is kind of from the southern part of Africa, because Africa was split into 2 or more segments throughout the Cretaceous by inland seas, kind of like how North America was too. So it could be that Northern Africa was separated, but Southern Africa was connected to South America or something like that too. And then the paper ends with the ubiquitous, we need to find more fossils.
Always.
They've talked about that a fair amount at SVP. I don't think we mentioned that before, but we have so few fossils to base these inferences on that it's never statistically powerful. So they're always like, yeah, go find more fossils and then we'll know.
Even when they have hundreds, it's not enough.
Yeah, because there are never hundreds of the same dinosaur.
Mm-hmm.
You go out and you look for more fossils and you end up finding just a bunch of new dinosaurs. But who knows? Maybe this time we will find more fossils and get statistical power to show how they were connected.
Sure.
Next up is an article by Jasmina Weiman and others published in Pure J. And basically, you might have seen this a while ago because we're a little bit behind because of SVP, but some dinosaur eggs were blue-green.
Pretty.
Yeah. So you may have seen blue-green eggs in the past. They range in colors that are super dark all the way up to really light, and you can see really dark ones with emu eggs and really light ones on kind of robin eggs. In fact, there's a color called robin egg blue that's pretty popular.
Maybe it should be changed to Oviraptor egg blue.
Or maybe not, because they weren't really the same color. But I'll get to that in a second.
Oh, okay. Maybe there should be a new color.
Yeah, there you go. So we've talked before about how egg pore size and sediment can help us tell if eggs were in open nests or if they were buried. And you may know that oviraptors are kind of the poster child for open nesting non-avian dinosaurs. And that's because there was an oviraptor that was found on top of eggs, and at the time they erroneously thought that it was trying to eat them, but later they discovered that it was likely just brooding them, so it was kind of sitting on them to keep them warm.
Too late for the name, though.
Yeah.
Egg thief.
Yeah. In this case, they looked mostly at the genus Heyuania, which is from China, and there's a few discoveries of it, ranging from near Beijing all the way down to the southernmost part of China. And it's about 70 million years old. And the researchers point out that covered or constantly guarded nests have white eggs, which includes things like alligators and turtles and lots of other animals. But colored eggs are unique to birds. And then on top of that, some cave-dwelling birds lose their coloration, which is kind of all pointing in the direction of colored eggs have evolved for open nesting sort of behavior, especially times when animals aren't near the nest. And there are a few reasons proposed for why uncovered nests have these pigments and coloration. One possibility is to camouflage the eggs with the surroundings. For instance, some eggs are brown and speckled and kind of look like, army camo. Like if you've ever seen a quail egg, they kind of have that look to them.
Quail eggs.
There's also the possibility to prevent nest parasitism. If you know about the cuckoo bird, it sneaks its egg in with other bird eggs, and a bird that isn't particularly good at telling that it has a nest parasite.
Very sneaky.
I think the egg actually does look pretty similar, but the cuckoo bird is like way bigger than the other birds once it hatches.
Nasty surprise.
Yeah. But if you have like a really complex pattern or a special color on your egg, that's obviously less likely to happen. And then finally, it might even protect the egg from solar radiation, kind of like sunscreen. So lots of reasons you might want coloration on your uncovered nest, but none of those really apply if it's in a cave or buried underground or if you're sitting on top of them the whole time. And much like how melanosomes dictate the color in dinosaur feathers, color in bird eggs is regulated by two chemicals as well. And these are both called tetrapyrols, and the two types are protoporphyrin, also known as PP, and biliverdin, also known as BV. Protoporphyrin, or PP, is reddish-brown, and biliverdin, or BV, is blue-green, which is kind of convenient because the blue one starts with a B. It's easier to remember than the pheomelanin and the eumelanin that don't have any nice trick like that.
That's true.
So anywho, previously the oldest evidence for colored bird eggs comes from the moa birds in New Zealand, which was about 1,000 years ago.
That's very new.
Yeah. And researchers have previously postulated that colored eggs are kind of a unique bird trait because no other modern animal that has eggs has colored eggs, which includes the weird mammals like platypus that lay eggs, all the different reptiles. None of them lay colored eggs except for birds. So the researchers used a pair of analyses to look at the eggs. They used both liquid chromatography and mass spectroscopy in order to make sure that they were carefully analyzing the chemicals. And because when other scientists have done work like this and they only use one technique, it makes it very susceptible for criticism. After their analysis, they found both of the tetrapyrols in the eggs, both the PP and BV, and they didn't find any in the surrounding rock, which is a really important distinction because if you find it there, then it's likely that it was just in the rock and it, during the process of fossilization, worked its way into the bone, and it just happened to be in the area.
Like the cuckoo bird.
Sort of, I guess.
I was thinking that would be a sneaky thing to do.
I guess so. Sneaky chemicals. But it didn't happen. Important to note.
Yep.
The spectra of the results does look really impressive. I have some familiarity with looking at all these types of spectra from my chemical background, and it's not really surprising, but the signals are quite a bit weaker for the fossils than the standard that they used, as well as weaker than the new emu sample that they compared it to. But the peaks are all in the right places and look really good. So combining those factoids, the researchers concluded that the eggs were likely colored, and it wasn't just a chance chemical in the area or contamination or anything like that. They also repeated the sample with 3 different sets of these eggs, and they found varying heights of the peaks, meaning different concentrations, but it all matched up in terms of what type of chemical it appeared to be in the spectroscopy. So I don't think that this article ended with the "we need to find more fossils" caveat that so many of them do. The most interesting thing to me was that they think that since the BV, or the blue-green chemical, is somewhat water-soluble, the eggs probably contained more BV when the eggs first fossilized than when they were tested by the scientists all those millions of years later. And that one, probably disproportionately was washed away over time compared to the one that makes it reddish brown. And because of that, when they strictly recreate the egg's color, from the recovered chemicals in the analysis, it gives kind of this really light gray-green color.
Yeah, I guess it's kind of like a tannish color with green hues.
But then once they added back some of the BV that probably dissolved, it makes it look much more like a dark turquoise kind of color. Not nearly as dark as an emu egg, which is just like super dark green. It almost reminds me of like the color of the Caribbean Sea a little bit.
I could see that.
One of the other features of concentrations of the PP chemical, the reddish-brown one, is that a lot of times it leads to spotted eggs, but they didn't think there was enough of it in their analysis to lead to a spotted egg. So it's probably a solid turquoise kind of color. And one of the coolest things is the implication for future scientific studies, where they say that, quote, chemically stable, relatively small biological molecules such as PP and BV appear to be protected from complete degradation over millions of years in carbonate biomineral matrices in an oxidative sediment milieu. Similar biomolecule preservation may be present in enamel, dentine, and bone mineral, end quote. Which is awesome. It's always amazing when they find chemicals like this and we can kind of interpret colors or, you know, whether the dinosaur was about to lay an egg and all sorts of cool stuff like that. So I'm hoping that people use more of this kind of analysis to find chemicals that we suspect might be there. And we can learn more about dinosaur behavior and what they looked like and things.
Very cool. In other dinosaur news, paleontologist Jordan Mallon has his Casmasoros skull. I think we've mentioned this before. When he and fellow researchers were waiting to get a helicopter to lift this 2,000-pound skull out of the Hilda Badlands in southern Alberta, the skull was found 2 years ago, and it's been taken to the Royal Tyrrell, where it will be packed and shipped to the Canadian Museum of Nature in Ottawa. And once researchers are done examining it, it'll be returned to Alberta and put on display. Scientists are hoping that the skull is going to help show whether Casmasoros canadensis had different skulls based on whether they were male or female, or if they were different species. There's some skulls that have been found that have long brow horns over the eye, and others have short ones. So the other cool thing about this skull is that Casmasoros specimens tend to be historical. They were actually found 100 years ago, so there aren't always the best records of where in the rocks they were found, but this one's new, so it has more information.
Oh, cool. I was wondering what you meant by they tend to be historical, but it's true that how information was published 100 years ago versus how it's published today is very different. It's way more rigorous now. And we have, you know, such big advances in things like stratigraphy, so we can find out better ages for the fossils and things like that.
Definitely. So yay, I know it. I remember reading a few news items about Jordan waiting for this helicopter to lift this skull out, so I'm glad it happened.
Yeah. Helicopters are expensive, it turns out.
Yeah.
And paleontology programs aren't usually the richest.
Yes. Next, in September, California finally named its official dinosaur, Augustinolophus. Yay! And it turns out that California is the third state this year to name an official state dinosaur. So Colorado was the first of all time to have a state dinosaur. They named Stegosaurus armatus back in 1982. Then 6 more states and D.C. named official dinosaurs between 1991 and 2009. And then nothing happened until this year, when Arkansas named Arkansaurus, Connecticut named Dilophosaurus, and California, of course, claimed Augustinolophus. So now 10 states plus D.C. have state dinosaurs, and we'll see what happens next year.
Yeah. And there are also a few states that have state fossils, which are dinosaurs, but they don't officially have a state dinosaur. So that's kind of weird. And then there's 1 or 2 states that have both a state fossil and a state dinosaur, but they're the same thing.
Different emblems.
I guess so.
Next, there's a whole bunch of museum news and cool events going on. So first, the University of Kansas Museum has a new T-Rex skeleton, and this skeleton was excavated over the past 4 summers in Montana, and its nickname is Lucy. David Burnham, a paleontologist at the university, worked with a team of students, volunteers, and donors, and together they found 25% of the skull, 60% of the hip bones, and 45% of the leg bones. And Lucy was probably 15 years old when she died, so check it out if you're near the University of Kansas. Next, the Western Australian Museum in Perth, Australia has a new exhibit from now until January 28th called Dinosaur Discovery, Lost Creatures of the Cretaceous. And that's at the Perth Convention and Exhibition Center. There's 23 dinosaurs, and it starts with Therizinosaurus, one of the weirdest ones. There's also Liaelinosaurus, Australovenator, Mutaburosaurus, Kunbarasaurus, and Carcharodontosaurus, as well as a number of Mongolian dinosaurs. So good mix.
Yeah, that's cool. Definitely some lesser-known dinosaurs, and a good showing of Australian ones.
Mm-hmm. The Academy of Natural Sciences of Drexel University also has a new exhibit called Tiny Titans, Dinosaur Eggs and Babies. It's a traveling exhibit, so Garrett and I actually saw it at the Philip J. Curry Museum in Alberta a couple years ago. You can see some amazing dinosaur eggs, and kids can also, well, and adults, we did this, dress as dinosaurs and hunt for eggs in the dig pits. There's no one else around, so it's totally fine.
Yeah, we did that, not just Sabrina.
You're an accomplice. Next, Extreme Dinosaurs, the exhibition, opens October 12th in Orlando. There will be skeletons and animatronic dinosaurs of Yangchuanosaurus, T-Rex, plus a baby T-Rex with feathers and more. And then the figures, they'll be able to blink, breathe, and even wag their tails. The animatronic dinosaurs have been in Calgary for the past 2 years, and then they were reassembled in Orlando, and the exhibit will be in Orlando for 1 year in a 9,000 square foot exhibition space near the intersection of I Drive and Carrier Drive, and admission will be $16.95. In Deadwood, South Dakota, Deadwood History Inc. is hosting a dinosaur workshop at the Days of 76 Museum on October 14th, which is a Saturday, from 10 a.m. to 12 p.m. It costs $11 for non-museum members, $6 if you're a member, and it's meant for students grades kindergarten through 6th. Reservations are required, and in the workshop, students learn about Sue the T-Rex, and they get to create their own dinosaur and excavate a fossil.
Interesting. Yeah. That's pretty close to the Black Hills Institute, too.
Mm-hmm. Next, Texas Energy Museum in Beaumont, Texas will have a dinosaur day on October 28th from 9 a.m. to 1 p.m. It's a free annual outdoor program with activities about dinosaurs and fossils, and kids can search for fossils and see specimens through microscopes, and all visitors can help make large papier-mâché dinosaurs. That sounds fun. And the last museum we have today, the Sam Noble, Oklahoma Museum of Natural History, is hosting a homeschool day on November 8th. Students can register now, and they'll have dinosaur programs for a bunch of ages, including a Meet the Dinosaurs program, where students can examine fossils, Dinosaur Feasts, where students compare fossils and modern animals to figure out how dinosaurs ate, and Mysteries of the Mesozoic, where students learn about an animal based on just one fossil. It costs $10 for one student and adult, and space is limited, so it's best to pre-register as soon as possible. You have to register anyway to go. Next, the BBC is making a film by Chris Packham, which will try to demystify T-Rex. It's called T-Rex, so there you go. And it will show, quote, the most accurate CGI representation of the fearsome creature ever produced, end quote, according to Radio Times. The CGI is going to be based on Tristan, the most complete T-Rex found so far.
Interesting.
Mm-hmm.
I wonder why they think it will be the most accurate representation. Like what kind of mouth they're going to give it and what kind of feathers and all that kind of stuff.
Oh, well, I think it'll be the newest representation of T-Rex. So based on that, most accurate to date.
I guess so. I've seen a lot of CGI representations of T-Rex, although not all of them are in video. They might be specifically referring to like full animated ones, because there are a lot of CGI created ones, you know, CGI modeled, and then they just show one picture of it for paleo art and things like that.
Just have to watch it and see. Next, Robert Legare, a photographer from Vancouver, British Columbia in Canada, has been taking photos of British Columbia with dinosaur models for the past year. So according to Daily Hive, he, quote, wanted to create a realistic snapshot of an amazing period in Earth's history and have some fun with modern day scenes too, end quote. And he also said he's drawn to sauropods, good man, and especially at portraying them as gentle and majestic despite their large size. And he also likes to portray T-Rex as parental and softer, and so he's got images of T-Rex families on beaches and by waterfalls. He gets his dinosaur models from a lot of different places, but he said he often repaints them because they're too flashy. And he sells his photos online and said he wants to make people smile and remember not to take life too seriously. He said, quote, "Most people consider dinosaurs only for kids for some reason, but I am here to say it's okay for adults to like them too. Never be ashamed," end quote. And yes, we agree completely. And last in the news, quick shout out. If you have Hulu or you watch any of your shows on Hulu, you can now stream the 90s TV show Dinosaurs. So enjoy that this weekend.
The Brian Henson creation.
Mm-hmm.
That's a pretty fun one.
It is. There's only 4 seasons. Perfect for binge watching.
You think everything's perfect for binge watching. And before we get into our dinosaur of the day, we want to remind everybody that we still have about half our slots for the Stegosaurus Patreon level available, but they're filling up pretty quickly. 24 of 50 have been claimed.
That is almost half.
It is. That's like 48%, in fact. So if you would like to join our Patreon and get a shout out, potentially with a fun dinosaur name like Paralorolophus, or if you'd like to join at one of our other levels to get an ad-free version of the show, or to get our books or audiobooks, or just access to our Patreon-only feed, then check out our Patreon page at patreon.com/iknowdino, or get the link from our show notes.
And now onto our dinosaur of the day, Antetonitrus, which was a request from Dinosaur 4602 via YouTube, so thanks. It was a sauropodiforme that lived in the Triassic-Jurassic boundary in what is now South Africa in the Elliot Formation. It was named in 2003 by Adam Yates, and also in the paper was co-authored by James Kitching. The type species and only species is Antetonitrus ingenipes. The name Antetonitrus means before the thunder, and it refers to the fact that this dinosaur existed before Brontosaurus and other known sauropods, but mostly Brontosaurus.
Because that one's thunder lizard.
Mm-hmm. And the species name means massive foot. Interesting name.
Yeah.
The fossils were found in 1981 by James Kitching, and they were stored at the Bernard Price Institute for Palaeontological Research in the University of the Witwatersrand in Johannesburg. These fossils were originally labeled as Euskelesaurus until Yates suggested that they were a separate taxon. The holotype consists of vertebrae and bones from the forelimb and hind limb. There's 5 limb bones from a smaller specimen that were also referred to Antetonitrus. The holotype was about 26 to 33 feet or 8 to 10 meters long, but the neural arches of the vertebrae were not fused with the centra, so it might not have been fully grown. It had a long neck, the skull's not known, and scientists think it was a mostly quadrupedal herbivore, but had primitive adaptations to use forelimbs for grasping in addition to supporting its weight, and its forelimbs were longer than its hind limbs. The first digit of its hand, the thumb or pollex, was still flexible and capable of grasping. Later sauropods had large, thick wrist bones, and their hands were locked in a way to support their weight full-time. Antetonitrus did have broader, thicker wrist bones, though, so that shows an adaptation. The feet were also showing the beginning of developing to support great weight. Also, the first toe on its foot had a claw, though it wasn't shaped exactly like later sauropods. So, Antetonitrus could be a translational link between bipedal sauropodomorphs and quadrupedal sauropods. It's not necessarily a direct ancestor to sauropods, however. Scientists have classified it as a sauropodiforme, which is an animal that has features related to the origin of sauropods. It closely resembles Bleikanosaurus and Lesimsaurus, but both of these are poorly known.
And our fun fact of the day is that back in 2007, the lead author on the Crustaceans in Poo article, Karen Shin,
that's a nice way to put it.
Yeah, also reported on dinosaurs eating wood back then, over 10 years ago now. And at that time, she was studying the Tomb Medicine Formation and coprolite believed to be from Maiasaura. So a little bit about that article. Maiasaura is from 74 to 80 million years ago, so kind of a similar time frame to the newer article. She identified the rock as coprolite by the fact that it had dung beetle burrows in it, and she cited a lack of twigs as evidence for them intentionally eating the wood. In other words, if they were eating leaves and, trying to eat parts of the plant that you'd typically expect an herbivore to eat, you'd expect them to be getting a lot of twigs and not necessarily like bulk wood from like the trunk of the tree. But what they found was that conifer wood, non-twig wood, accounted for 13 to 85% of each coprolite. 85% is crazy.
Yeah.
That's so much wood in your body. But this wood was also decaying. They could tell because of fungus that was in it. And that possibly means that the fungus broke down the wood into something that was bioavailable for Maiasaura or whatever hadrosaur was eating it. That's important because even though hadrosaurs have these great grinding teeth and massive stomachs, they still probably couldn't get much nutritional value from wood without something like a fungal decomposition going, or it could just be that they were getting nutrition from the fungus itself. And at the time, Chin cited this as a potentially useful resource given the overall lack of grasses and other angiosperms that modern herbivores prefer to eat. So degrading wood, I guess, is a close second.
Dinosaurs had an awful diet.
Yeah. Although I'm wondering if she's going to go back and look at these coprolites and see if she can find any crustaceans in them, because it might be that they were doing the same kind of thing.
Interesting point. And that wraps up this episode of I Know Dino. Thanks for listening. Please don't forget to subscribe to us so that you don't miss out on any episodes. And if you want to join our growing group of awesome patrons, check out our page at patreon.com/iknowdino. Thanks again, and until next time.
Thank you for listening to I Know Dino. If you have any questions or comments about dinosaurs, we'd like to hear from you at plesiosaur@iknowdino.com. And for more information on dinosaurs, go to iknowdino.com or follow us on Google, Facebook, Tumblr, or Twitter at I Know Dino.